Okay, my dear students, before we start, I would like you to reflect on this verse, John chapter 20, verse 29. Jesus said to him, "Have you believed because you have seen me? Blessed are those who have not seen and yet have believed." In relation to this verse, I would like you to ask yourself, do you believe in God despite the fact that you cannot see Him? So to help us journey this question, we will have our lesson, which is EM spectrum. The focus of this lesson or this video are the following. First, describe the nature of EM waves. Second, discuss the relationship of wavelength, frequency, and energy level of EM waves among each other. Then lastly, compare the relative wavelengths of different forms of electromagnetic waves. At the end of the lesson, we will try to answer confidently these questions. First, why do astronauts use radios in space in order to communicate to each other? Second, how will you describe the relationship of wavelength, frequency, and energy level of EM waves among each other? Then lastly, why gamma rays are usually denoted as harmful? To begin with, let us differentiate first longitudinal waves and transverse wave. So first, I have here an animation of longitudinal wave or its representation. The motion of its particle is moving horizontally, while its wave itself is moving horizontally as well. Now, are they parallel with each other? Or are they perpendicular with each other? Okay, later on we will discover that one. Then we have transverse wave. I have here another representation. As you can see, the motion of its particle is going vertically, while the motion of its energy or its wave itself is moving horizontally. Now, are they parallel with each other or are they perpendicular with each other? Now, I want you to differentiate the two, the longitudinal waves and the transverse waves. Are they the same? Okay, let us see if you have a correct answer. So if you're talking about longitudinal waves, don't forget the keyword is parallel, because the motion of the particle and its wave itself are parallel with each other. While if we're talking about transverse wave, the keyword is perpendicular, because the motion of its particle and its wave are perpendicular with each other. Now, do you have any idea what are the examples of these waves? I think one of the examples you have in mind is sound wave. But is it a longitudinal wave or a transverse wave? I want you to observe the motion of the sound wave of a human voice. Let us see if you're correct. That is longitudinal wave, because the motion of its particle and its wave are parallel with each other. So one of the examples of a longitudinal wave is sound wave. Now, I have here EM wave. I want you to observe the motion of its particle and the motion of its wave. Are they parallel with each other or are they perpendicular with each other? Okay, so they are perpendicular with each other. Therefore, it is transverse wave. So one of the examples of transverse wave is EM waves. Now that we have already differentiated longitudinal wave and transverse wave, let us now differentiate sound wave and EM waves. Don't forget, if you are talking about sound wave, it needs medium in order to propagate, while EM wave doesn't need. Now, these ideas can answer this question. Why do astronauts cannot hear each other in the outer space even if they shout to each other? Before answering that, I would like you to know that space is a vacuum. So if it is a vacuum, it doesn't have an ample amount of particles or medium. So if that is the case, can sound wave travel in it? No, because sound wave needs medium in order to propagate. So, if they cannot hear each other in space using their own sound waves, how do they communicate with each other? Or, what type of wave can be used to make their communication be possible, and why? You're correct. We have to use an EM wave. Because EM wave doesn't need medium in order to propagate. Another point of difference between the two is their speed. If you can still remember in your grade 8 lesson, is sound wave has a constant speed? No, because it varies depending on its medium and temperature where it is traveling. Whereas if we are talking about the speed of EM wave, it depends as well on the medium. However, if it is traveling in a vacuum, it has a constant speed of 300 million meters per second, same as with the speed of light. Why? Because light is a form of EM wave. That is the reason why as well, why EM wave is sometimes called EM radiation. By this time, let us focus on EM waves. If we are talking about EM waves, it has two major components. These are electric field and magnetic field. Another thing about EM waves, it has wide range of frequencies, wavelengths, and energies. Now, let's have a quick review of what are these. First, wavelength is the distance between two successive crests, as you can see in the picture. It is measured in meters. Now, if you're talking about frequency, it is referring to the amount of waves passing through one point to another in a specific period of time. If wavelength is measured in meters, frequency is measured in hertz. Okay, another point about frequency is it is directly proportional to energy. So if that is the case, if frequency will increase, what will happen to the energy level? Okay, it will also decrease. This time, I have an animation for us to compare wavelength, frequency, and energy level. In this picture, what happens whenever wavelength will decrease? What happens to the frequency? Okay, so whenever the wavelength will decrease, the frequency will increase. Okay, so let's have an example. If wavelength will increase, what will happen to the frequency? It will decrease. So, if frequency and energy level are directly proportional with each other, what will happen to the energy if the frequency will decrease? Okay, it will also decrease. So how about when the wavelength will decrease? What will happen to the frequency and energy level? Okay, they will increase. So what can you conclude? Wavelength is inversely proportional to frequency and energy. So let us apply this as we have EM spectrum. But what is EM spectrum? EM spectrum refers to the range of EM radiation or EM waves arranged according to wavelength, frequency, and energy level. Just like what you did earlier. Now, it includes radio waves, microwave, infrared, visible light, UV rays, X-ray, and gamma rays. Don't forget, among this, the only wave that you can see or that can be detected by your naked eyes is visible light. Okay, it doesn't mean that if the others cannot be seen by your eyes, they do not exist already. At this point, we will compare the wavelength, frequency, and energy level of each region of EM spectrum. We will do this using this image. This image, at the top of this, you can see numbers. The numbers or these numbers represent the size of the wavelength of each region. Now, for us to visualize this easily, we have here at the bottom objects. The actual size of these objects can be compared to the size of the wavelength of each region. For example, for radio waves, the size of its wavelength can be compared to the actual size of the buildings or to humans. Okay? For microwaves, its size or its wavelength can be compared to a honeybee. For infrared is to pinhead. For visible light is to protozoans. For ultraviolet is to molecules. For X-ray is to atoms. For gamma rays is to atomic nuclei. Now with this, which one has the longest wavelength? Of course, the radio waves. Which one has the shortest wavelength? Okay, the gamma rays. Now, I want you to describe the size of the wavelength from radio waves to gamma rays. Is it decreasing or is it increasing? Obviously, it is decreasing. So, from radio waves to gamma rays, the wavelength is decreasing. If that is the case, how will you describe the amount of frequency and energy level from radio waves to gamma rays? Is it decreasing or increasing? Okay, it is increasing because as we have discussed earlier, the relationship of wavelength to frequency and energy level is always inversely proportional. Now, among these regions, which one has the highest amount of frequency and energy level? Okay, it is the gamma rays. This is the reason why gamma rays are usually denoted as harmful because of its high amount of energy. Now let's have a practice between microwave and infrared. Which one has highest or higher wavelength? Okay, it is the microwave. But which one has higher frequency and energy level? It is the infrared. Okay, so hopefully you've learned something in this video. With all this, hopefully you could answer already these following questions. To end this, we will have another set of questions. First, what if there's no EM radiation? Second, what if there's too much EM radiation? You will discover all of this as you do your next activity. God bless